Okay, guys. First of all, I'm sorry that I can't make it today on Monday, July 20th. We still have exam on Wednesday, July 22nd. So please keep in mind, and our exam will focus on chapter 13. So please be able to do those. I'm gonna give you a recap on what we need to do on the exam, anyways. Okay. So first of all is that chapter 13, we're going to skip chapter 13.9 on that application for the moment. We have the chance, we'll come back and do that. More importantly, this is the overall view, what that section is about. It's called Lagrange multiplier. So Lagrange is a French mathematician. He published these papers when he turned 19. But when he introduced this guy here, and it's very cool concept. And he introduced this by the intro back in the day. He called this is the classical milkmaid problem. And let me define to you why I say that he is so nice about we associate milk and maid. So I don't know, something maybe funny about it. But however, what is milkmaid problem? I mean, it would be nice if I ask you how far, right? How far do you travel from this location A, let's call this location M, named Mary, to this location X here is for cow, right? Mary and a cow. And of course, what is the shortest distance between this is a straight line that connects these 2 points. Those are the minimum distance. That's define what distance is about. But here's the continuation of this guy here. This person here live along the river. Okay, imagine this is a river. Okay, a river bank. And the question now is that Mary have a very dirty bucket before go out and milk the cow. So the first thing first, she have to rinse the bucket at the river. So the question is, at which point along the river so that she can go rinse her bucket and go to the cow? And which point is the shortest? As you notice that here, there are infinitely many ways to go there, but the only way you can get to the cow after rinsing the bucket, there should be only one, maybe more than one way, but which way is the shortest? So this is called milkmaid problem. And the way that Lagrange come up with this idea here is how do I solve this? Quite hard, you know, which point should I go to on the riverbank to wash my bucket so I can go to the cow? So he comes with this idea. He generate an ellipsoid and use those 2 points as the foci of the ellipse. Whatever the first ellipse that touch the riverbank, that is the point that he should travel. And he have that proof, and he published that paper when he was 19. That's fascinating. But how do they come from? What is this mean? Now, Lagrange multiplier is a way that the concept of Lagrange is this. We like to maximize or minimize this function here. What if you have a function that you have to maximize or minimize? But every time you maximize or minimize something, there's also be a constraint. So there is a constraint here. So this is subject to the following: g of x comma y equal to 0. So every time we can set this equal to 0, okay, and we'd like to find out what that is. Okay, what is the constraint to that thing is. So it's, in other words, is what if I said how to maximize my profit subject to that my cost is equal to $100 or something like that. What if I want to make everybody happy that my functions I only have $100 to deal with. So that's what I want to do. The question now is, how do I solve that? How do I solve that? Okay, how do we solve that?